Hello guys, welcome to another matplotlib tutorial in Python. So in this video tutorial we're going to discuss about scatter plots. Scatter plots are quite interesting and it's quite different from the other plotting techniques that we saw in our previous tutorial. It's gonna let you to see the trend or like where the masses are, like where the data actually lie, like I mean, in the x and y axis, like where it actually lies, in which portion. So that's quite interesting about that. So what we're going to do in this tutorial is like we're going to use NumPy's random number generator function to like generate few random number for the x and y axis, and then we're going to like plot it out and see like how 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 helpful this scatter plot is to visualize the trend in a huge data set. So let's get straight into it. First, let's import numpy as np import matplotlib dot pyplot as plt. Let's generate some random number x1 is gonna be like 5 star np dot random dot rand 40. So it's gonna generate 40 random numbers between -5 and +5. That's what the above code actually does. Let me go down and like copy paste it. So this is for x2 and this is for x3. So what this, let's call it x2 and x3 first, x2 and x3. So what this actually gonna does, what this line of code is actually gonna do is we're gonna add 25 to all the value that are being generated, and then we're going to multiply this. It's sort of like an outliner, so we're going to multiply this by 25. Then we're going to reduce the number of numbers generated by 20. So and then together we're going to call it as x. So how am I going to do this? We're going to use numpy's concatenate function. Concatenate. It's going to take all these three numbers that we generated as an argument, x1 comma x2 comma x3, close this one. So in a similar fashion we're going to generate the numbers for y. Copy paste and also this one. So let's call them all like y1, y2, y3, y. So rest all same. So we concatenate y values, y, y, and y. So we're going to plot them. So plt dot scatter scatter x comma y. Save dot show save file. Let's see what it does. Here we go. We got a scatter plot. Looks so. This one is this junk, and this one and this one is this junk. It's over here. No, this one and this one is this junk. It's over here, and the rest are outliners. So let's tweak our parameters for plotting. Let's make it look a bit attractive. Well, let's try to get a control over plot. Comma s equals 100. I don't know what it does, so we're gonna see that. Marker, I know what it does. It's gonna like specify the kind of marker that you want on data points. Then comma C, this C is color. We want magenta, so and save and F5. Here we go, we got this. Let's see, it looks correct. Actually, let's get rid of this one and see what difference does it make. Save, close, F5. Ha 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 ha. Save, desktop, save, yes, close, Control C, save, F5. Oh, the size of the marker. Let's go and open the figure one. Here we go, the size of the marker is the one that, yeah, the size. Let's go ahead and play with that parameter a bit to see the effect that it has. Let's give it 1000. Here we go, it's actually size. So you could adjust the size of the marker using this one. And then next, let's try to give different color to different group of data. So what we're going to do is we're going to give the size as 50. We keep all the data that we generated and saved over here as what it is. So now let's define a color array. You call it an array. It's going to be equal to, so it's going to be blue star 50, blue star 50 plus green star 50 plus red star 25. And then instead of magenta, you pass this as an argument for the color. Save. Let's execute and see what it actually does. Let's close this one. Save, run. F5. Oh shit. F5. So it's actually differentiating it, but I don't know what effect this this actually has on this one. I don't see any red colors now. Okay, so now this helps you to like differentiate between the colors. So all the upper and lower limits, the upper limit is actually green, the lower limit is actually blue, and then the rest should be red. I think that's some problem. So I think we could just close this one and like move on. Let's try to show some correlation on this, like how it's all correlated. So let's close this one first. So we want to figure out a correlation between x and y. So for that, you actually have a cool function in NumPy. So let's create another variable z. Then NumPy np dot polyfit. We want to fit x and y value in this, and then the degree of the polynomial. So it's going to be first degree polynomial. So it's something in algebra, first degree mx ax plus by equals c. That's first degree. Ax square plus ax square plus bx plus c. I think it's actually second degree. Yeah. So we're just gonna fit this according to first degree polynomial, the x and y values, and then we're gonna generate data point out of that first degree polynomial. So np dot. So actually, this thing is actually creating an equation. That's what it does, and out of that equation, we are going to generate the data points. So that's what poly 1d. So for this one, we want to create the data point. So this line of code actually creates a data point. So now we are going to pass p. We're going to plot a line between plt dot. I think we have to import PyLab to do that plotting. plb dot plot x comma. So for these value of x, I want the corresponding value from this equation. So we have to specify that. So the whatever value the x is going to generate corresponding value based on this equation that's created over there. So then let's close this one, save this one, and then press F5 to execute this. So it's actually plotted the graph for us. So it's actually a trend. So it's actually data points with a positive slope. So that's what it is. I think we almost there. But let's just randomize this and make it a bit messy with. Let's just make it a bit messy so that our graph looks a bit complex, and then they all think that we're doing something that's really complex, or at least you get to know the complex data point that you could make a sense out of using matplotlib.pylab functions. Okay, 15 pass 50, 50, and 30, and do the same for y values. 15, 50, 50, and 30, 30, and 15. Save this. The rest remains the same. The size, let it be 50, just don't care. Let's change the marker, let's make it all look like stars. I think almost there. Save this and execute. So here we go. We go to see the outliners here. So these are represents the outliners, and the rest are pretty much closer to the graph. I mean the line that we fit. The one that are too far away are in red. So I think now we can do pretty much almost everything in scatterplot. If you guys want to do furthermore in this, then obviously you could refer the documentation. If not, comment below, I'll try to answer it if I can do it. Thanks for watching. Like the video, subscribe to the channel for more videos. Like my Facebook page. You can find the link to my Facebook page in the description. In my Facebook page, you get to know the new videos that I'm making. I'll just keep posting all the new videos that I'm making on my Facebook page. So like the Facebook page to keep you all updated with my video series. Thanks for watching. Talk to you guys in the next video tutorial. Bye for now.